I don't know how riveting this is going to be. I'm not usually very riveting, but we are having some fun, and I want to give you a chance to see what we're doing. And I really appreciate Lewis sending me an invitation to do this. This is something you kind of put on the highest priority, I think, is to come and talk to you guys. So thanks for doing that. There are people out there, and I've heard almost everybody I've talked to actually says that year in the middle, 2010, was the strangest, most challenging year that they've ever had. And these are guys that go all the way back to Apollo and the transition between Apollo and Shuttle. I can tell you that it is not mine, and I'm not sure why they say that, but it might make my top 5. Yeah, there's no doubt 2010 was a very challenging year for us. And a lot of it was because our bosses on the two ends of Pennsylvania Avenue weren't decided about what they wanted NASA to do. But we're starting to get some clarity around that. It is clear to everybody that we need a heavy launch vehicle. It is not very clear how heavy that heavy launch vehicle needs to be, and we've tried to put some clarity around that. But you can see that some of our policy statements starts looking a lot like requirements when policy says it will be 70 to 100 tons, and our most recent appropriation language in the CR says specifically at least 130 tons. So that starts looking like a requirement coming out of the Hill, and we think we can do that. This is the chart that John showed, and again, the Space Launch System is at the front end of all of this, and unless we get to MPCV and the heavy launch vehicle, we're not going to go very far on this roadmap. There's another thing going on out there that's bothering people a lot, and that's this idea of capability-based development. I think that's coming from folks who went through Constellation with a fixed defined mission. People can't seem to take on the design without a design reference mission to go design to. A lot of us remember shuttle development, and I think shuttle was a capability-driven development. It was designed for a lot of uses, and we didn't know and couldn't even imagine at the time what all the uses that shuttle would be used for. And so I feel like we can take that approach with a heavy launch vehicle, and I feel like we are doing that. This is the process we've been on, and I just want to make sure everybody knows that we're making progress and we're moving forward. I get bothered every time somebody suggests another launch vehicle study. I went and did a study of my own one time looking at the numbers of studies that we've done, and it's well over 2,000 launch vehicle studies in the last 10 years. But when you look at them, it's hard to get them on the same guidelines and assumptions. It's hard to tell the story to somebody who hasn't been involved in that particular study. Every new president wants his own study. Every new manager wants his own study. And so I've given up and decided to do any study that anybody asks me to do. We're getting pretty good at it. We can do launch vehicle studies. Right after the report came out from the Augustine panel, we went forward with a heavy lift study. We actually asked to do this because it turned out everybody in the world was out there doing launch vehicle studies, and we felt like we needed to gather those up under the same assumptions and same guidelines and tell the story apples to apples. So we did that, and many of you may have heard of the McConaughey study. that basically pulled together a good set of data. It eliminated some options. It brought some new options in. It basically gave us a set of designs that we felt pretty confident in, that we had the same guidelines and assumptions, and we could compare those head to head as we went forward. Then the President's budget came out, and the President's budget basically eliminated Constellation. Of course, we were expecting that. It eliminated Ares, but it put a big focus on technology, specifically, very specifically, a new RP rocket engine, big RP rocket engine. And when we finally traced that down, we found out that the Air Force was extremely interested in a new engine to replace the RD-180. And so we found that that's where that came from. And so we took went up and proposed to OMB that we do a joint study with the Air Force, which is not a new thing for us. And we made contact with some folks that we remembered from the mid-90s. And we did a joint study with the Air Force looking at, can we get to a common rocket engine that would be retrofittable for the Atlas vehicles and would be usable for the NASA Heavy vehicle. And we came up with one. We came up with one that was about 1 to 1.25 million pound thrust, possibly evolving to 2 million pound thrust. And OMB was very happy with us for doing that. Then a lot of the language started to come out of the Hill on, we now had the President's budget proposal. We had proposed authorization language from Congress, both houses of Congress. We had some appropriations, draft appropriations language from Congress. So we took the vehicles that were developed in the McConaughey study earlier, and we put that through a figures of merit analysis based on what we thought our stakeholders were telling us they wanted. And it ranged anywhere from 70 to 100 ton launch vehicle to safe, being able to fly crew, to using existing contracts to the maximum extent practicable, and figuring that word practicable out was fun too. It included maintaining the existing workforce. It included a lot of words that we ran these vehicles through that figure of merit, and that's the way we came up with our reference mission. Now, at the same time, the HEFT 1 was going on. HEFT 1 produced a budget target for us, and we ran those vehicles through that budget target, and lo and behold, we had a vehicle that met that target. We found out probably a day later that budget target was not a good budget target. Our budget target was much lower than that, so we found that all of those vehicles were basically unaffordable. And that kicked off another study that we have called the requirements analysis cycle. Many of you who are systems engineers understand what a rack cycle is, and I'll talk a little bit more about that as we go forward. But that has basically gotten us to a mission concept review, which we have passed. We had an independent team sit with us on that, and we believe we will get permission to move forward into formulation based on that analysis. And that puts us towards what we now call KDP-A, which is approval by NASA to move forward into formulation. So this says some of that. One thing that I didn't talk about was we put out at the same time a BAA to 13 different contractors to do an evaluation. We gave them a little bit of money to go look at launch vehicle options around different architectures that they would propose. And we have some of those guys looking at in-space refueling and other architectural options, and as well as launch vehicles. But those are feeding our requirements and analysis cycle. We kicked off the racks on November the 4th, and it was our idea was to, rather than going through the normal process of trade studies against multiple vehicle options to see if they meet our requirements, we decided to run 3 teams in parallel. And that way we felt like we could cover 3 very diverse options on the vehicle architecture, run them in parallel, and basically did 3 requirements analysis cycles at the same time to get ourselves to being able to propose to NASA headquarters that we have options for meeting the requirements that you've given us. And that's all we have to do for MCR, by the way. We don't have to have an exact option, one option. Heft 1 generated a set of level 1 requirements for us, and I'll show you what those look like. Like I said, we have gone through the mission concept review and passed, I think, with flying colors. If you are interested in what a rack cycle looks like, this is what a rack cycle looks like, and this is the kind of products that get generated. You start by generating how you're going to operate the vehicle, what functions each piece of the vehicle, and as well as the ground and flight systems are going to play. And you basically generate, based on the level 1 requirements that you've been given from headquarters, a system requirements document. And we produced 3 of those, each for each of the vehicles. We did a checkpoint at that point, and then we tested our vehicle system designs against those requirements. In some cases, we pushed back on the requirements. In other cases, we changed our vehicle design to try to meet that. Our development plan was generated, and we generated a set of affordability cost numbers, and with a very clear basis of estimate. One thing we looked at these teams was, what's your basis of estimate of cost? And then we looked at risk and shortfalls and technology assessments on the way. The main purpose is to get to a system requirements review that you feel good that I have good requirements to design to before you go out on contract and start trying to tell a contractor to go build this vehicle and start making changes. And so what we found in the past, and all of you know this that's been in the business for very long, when you start changing contracts and changing requirements on the contractors, your price goes exponentially high. And so we're trying to avoid that. These were the 3 rack teams. We actually put 4 teams together, one generically looking at affordability processes and how we build affordability into our normal design processes. We had one vehicle that was a hydrogen core vehicle. We left it at that. We said you could use solid boosters, you can use liquid boosters, you can use RS-68s, SSMEs, you can use a new engine if you want to. We had one vehicle that what I would call a Saturn V kind of derivative vehicle. It was a RP first stage, hydrogen second stage. We allowed them to trade the kinds of engines, the size of the tankage, and all of those. And then we had something that was added in Heft 2 when they started looking at sustainability. One thing that we know is that NASA cannot continue to own large, unique infrastructure across this country and afford it to create a wedge for future development. So we started looking at what we call a modular design, and it's basically using existing either commercial or sharing infrastructure with the Department of Defense and see if we could save infrastructure and downsize our basic aerospace infrastructure and share across all of our launch systems. And I'll show you what that one looks like in a minute. Major objective was affordability. Build affordability into your design up front. Go show me that we can design to cost, that we can actually implement cost into the design solution. We have never done that before that I know in NASA. I know industry has done it. PWR did it on the RS-68. That was a design to cost engine. But I don't think we've ever done it anything that I've been involved in. We went through an initial development cycle for the requirements, and I asked each of the teams to test what I call a lean systems engineering process. It's a process that's very unstructured and is built around the idea that we have experts at each of the interfaces that understand how to put a system together. So I basically gave them a systems engineering structure to go test and see how that worked, and I got written feedback from all the teams on how that was implemented. We collaborated with almost all the centers. We gave them a definition of affordability, which everybody had a definition of affordability, so we made up our own. But we think it's pretty close. We think you've got to stay within the ability of the country's means, and that changes over time. Right now it's pretty tight, to do this development and to operate it. And it has to be sustainable. And the sustainable part means that I can't use up all of my budget launching things. I have to create a wedge of budget in the future to go build new things. So if I'm going to expand my horizons across the universe, I'm going to have to be able to add capability, just like John's roadmap shows, and how you're going to afford that. We're not going to get a huge influx of money one day and tell us to go build large HABs for doing a NEA mission. We're going to have to create that budget by reducing the cost of launching things. So our production and operations costs get very critical to us. And it covers all aspects of cost, not just development cost and operation costs, but it covers the price of testing, manufacturing, and sustaining both fixed and variable cost of the operation. So we included all of those in the study. One thing that we wanted to consider is this approach of block upgrades. And I got really enamored by watching Steve Jobs, how he releases products. And he's basically on a block upgrade kind of approach. He'll release a product when most of the people on his team thinks it's not ready to release. It doesn't have the features in it that they want, but he releases it anyway. He's the only one in the company that can say no to a feature and tell them where to go. So our affordability team, just to say a word about that, I think this is the only time I've ever shown these results. They got input into the individual rack cycles. But one thing that came out of that study was that affordability has to be organic with the management and engineering processes of the design. You can't have an affordability czar or a special office for affordability or something like that. Affordability becomes just like performance or safety or anything else as you go through the design, and we try to build that into the rack teams. It is a design driver, which means you got to start thinking about it now, and you got to put requirements on how you manage affordability as you go through. The early effort to solidify the requirements, that's what the rack teams is all about, is get the requirements down solid before we go out on contract and buy anything. Time to market. Almost every company out there that's making money will tell you their number one priority is getting their product to market to beat everybody else. We are very slow in our development processes when it gets to major space systems like launch vehicles. So we've got to learn to get our systems out, and that's what the block upgrade kind of philosophy maybe can do for you. And then we looked at the things that Constellation was pulling together on lessons learned. Some of the shuttle groups are doing that as well, and you've seen that this week. We started going down through and just looking at the systems engineering processes, the way we make decisions, how we gum up and make it so cumbersome to get a decision made on being able to move forward. We had a situation on an access door on upper stage that went 4 years the whole time without a decision. When we finally got to make it, we had to make a change in the Boeing contract to make that design. That is unacceptable. Those decisions have to be, you have to know when the right time to make the decision is, you got to make them and move forward. Our inside oversight models, industry tells us that drives cost on their side to the tune of possibly 3 times more people than we put on it. I'm not sure I believe that. I think it may be at best 1-to-1 or some increase, but we have to do something about how we do oversight on our contracts. Are we going to ask them to provide us all this data that we normally ask for and don't look at? Or are we going to ask for just what we need when we need it? And so that's how we're trying to organize the most recent contract to try to reduce cost on the contract side. The design is important. Simplifying the design is really important. Design is not generally an engineering discipline. System design. I sit on 2 engineering boards, and I've sat on more than that at universities, and I constantly pound on them to get system design into their curriculum, and they struggle to do that. Some of them are starting to make progress by doing that, but we basically learn system design on the job. You've got to be able to look at it at the system level, and you have to be able to say no. That is something that we just don't need. It's the Steve Jobs approach to system design. And I am not opposed to complexity. I'm not one of these people that think you can simplify launch vehicles down to the point where anybody on the street can go design a launch vehicle. But I am opposed to over-complexity, and I think we do that a lot. And so we're in the process. I asked my team to take a pledge recently, and I asked the RAC team to take a pledge, and that pledge is pledge to do imperfect work. Engineers have a hard time with that. They can't hardly get their hand up to make that pledge. But we've got to do it. This is how Heft gave us the requirements. I thought it was an excellent way to give us requirements, because what they gave us was a threshold requirement. You cannot not make that threshold requirement. And then they gave us a set of goals as we really want you to shoot for that goal. But I'm going to allow you to trade all of these requirements within that band. And so if I've got a lot of schedule margin, for example, I can trade schedule for safety or for performance. And so this allowed us to do that. And you can see we've got some pretty aggressive cost requirements in there with a goal of $1.2 billion annual recurring cost. That's annual recurring cost for 2 launches a year for this launch vehicle is quite aggressive. We didn't have anybody that could meet that, by the way, but we had everybody that could meet the $1.75 billion annual recurring cost. And so you can see we drove costs from the requirements on down. I got to say something about rack team dynamics, and Spike over here can back me up on this. Or we had a lot of fun with this, and I told the teams that this was serious work. If we can't get the cost down of launch vehicles, we may not end up building a launch vehicle. They're going to let SpaceX or somebody else go build it for us, and we won't even be involved in it. So all I had to say was, the winner, I will pay for pizza and beer. And I've never seen such scrambling and beating each other up and fights in the hall. And it was the most fun we've had in a long time, and I actually had to buy one team pizza and beer. And that was our team 2, and Spike was a member of that team, so you're welcome. I think we learned something from every one of those teams. We had one team that really drove design to cost. They basically set a set of cost requirements down to the subsystem level and forced those guys to show them how they could get in that cost, and they checked them once a week to see how they were doing. We had one team that was on the simplicity, margin, and simple processes idea, and that was team 2, and that turned out to be very effective. It turns out, and Russ Rhodes and I have talked about this for years, if you can put performance margin in the vehicle, you can relax so many other things that you can drive cost down significantly. And Russ actually has a model that shows that. Finally, everybody wants to see the rockets and talk about the rockets, and so I will do that for a minute. We basically had 3 versions of rockets that came out of this team. One is the hydrogen-based rockets that looks a lot like shuttle drive. They determined that SSME was the better choice for that vehicle, and they really used the block approach, starting with a vehicle that could fly in 2016 and carry 70 tons capability, including crew, evolving to a 100-ton vehicle, and then finally to a 130-ton vehicle. It was an excellent use of block upgrades of the vehicle. The other team really simplified and went after performance margin. This vehicle has huge performance margins. It has so much performance margin that I can meet my performance goal with engine out on both stages and drive my loss of crew numbers to an outrageous 1 in 3,000 kind of number. It's a designer's dream. This vehicle, this team took the objective and set the goal of, I'm going to get all the cost out of the hardware. And by doing that, they basically took existing hardware in current manufacturing, and they created a launch vehicle out of the existing capability that we now have in the country. It turns out to be something that, as a designer, I would call ugly. Their answer to that is, it may be ugly, but we're smart. So, so we're still looking at this vehicle. I can tell you some pluses and minuses. This vehicle starts fast at a relatively low cost, is about the only thing we've got that can meet a 2016 kind of launch date. Its recurring cost is relatively high, and we have not found a way to drive the recurring cost of throwing SSMEs and those big solid boosters away. This vehicle, it has huge performance margin. You can open up the trade space. We think we can do design much easier on this vehicle. It basically has a F1A. Those of you familiar with the Apollo engines, it was an upgrade to the F1 engine. A relatively simple engine and a simple configuration. KSC loves this vehicle. Because it's easy to operate. Its negative is upfront cost. So you have to be able to pay upfront for a vehicle like that to get the goodness out of it. This vehicle's problem is generally integration complexity, which we believe wasn't assessed maybe as well as it could have been as cost, and it has trouble meeting the loss of crew requirement. You cannot get engine out in this vehicle. It has so many pieces and parts that when you do the probabilistic analysis on that vehicle, its loss of crew numbers are relatively low. In fact, it didn't meet the threshold requirement. Now, there's ways around that. There's other options. You have to give something up. You give up a little operations and production costs for a little more loss of crew by eliminating the number of systems you have. So in summary, we told our MCR board and our independent assessors that we believed we could even meet a lower budget requirement than these teams were operating to. And we think we've got to be able to get within the $2.8 billion for the whole integrated system. That includes MPCV and the launch vehicle and the ground systems to be able to develop this vehicle, and we think the budget's going to be relatively flat. And all of you know that have developed things before, flat budgets and development just does not go together. It will end up costing us way more by keeping the development in a flat budget, because what you do is you end up extending the time. You can never get people on and off the program in that time, so you're basically maintaining an engineering fixed cost that turns out to be very, very expensive when you stretch it out. I would like to be able to convince folks that that's the case, but we haven't been able to do that. The budget is what it is, the country is where it is, and we've got to figure out a way to be innovative and fit into a budget like that. We think there's ways to do that. We think a relaxed set of mission requirements would allow us to fit in that budget. That is, if you allow us to split crew and cargo, for example, I could fly a very safe mission with a crew on it with that vehicle 3, for example, but I can't carry much payload with it. And then if you will allow me to reduce my loss of mission numbers to something that it could do, I could put the full system up and put the heavy cargo up with it. That's just an example of what you can do. Same thing is true for vehicle 2. I can either have engine out, I can have no engine out, I can carry a 150-ton payload with no engine out, and I can carry a 105-ton payload with engine out on both stages. So if you allow me to manage my payloads and my crew, then I may be able to do what you want me to do. The other thing to do it, the other way to do it may be to allow us to manage the requirements in a phased approach. That is, you can tell me that my performance requirement is 130 tons, but maybe I will tell you that I will get there by going through 70 tons and then 100 tons and then 130 tons. And my final capability will be a 130-ton vehicle, but I'm going to be flying payloads and doing missions, crewed missions, with a 70-ton launcher. And to me, that makes a lot of sense if you don't tie me completely down so I have both hands behind my back instead of one. We think we can get there. The BAAs have provided pretty good input for 650K a piece. All of these guys are really interested in us hearing what they have to say because they want to be involved in the development of the next big launch vehicle. So I'm guessing they're spending a lot of their own money doing some of this. But they're providing us some innovative ideas, and some of the companies have actually provided us price points and cost analysis that allows us to go and actually evaluate one-to-one. Can they really do this at that cost? Can they do what we don't think we can do? Because when we go test their numbers using NAFCOM and our parametric analysis, we have a hard time figuring out how in the world they could price something like that. Is it worth going with them and testing them on a fixed price contract? Maybe, maybe not. Maybe we can get some confidence in these guys that they can really do that. With the multiple concepts we've got, we believe we've got significant flexibility to deal with maturing mission requirements. I personally have no problem with a capability-based development. I really think that's something that we can do. I think the missions can evolve, and I think we can be there when the mission is ready to be there. So I think we've got the flexibility to do that. We basically recommended to the MCR board that they allow us to proceed into to mature the feasibility of these concepts, basically go into formulation of the program. That's starting to come about now. We asked for a stable, internally consistent set of level 1 requirements. We now have a baseline set of requirements from level 1. That is unusual for us to get a set of level 1 requirements this early in the process. So our John's guys and Helen Grant and the folks at headquarters are doing an outstanding job of working with us and trying to drive out requirements for us so that we can nail those from the beginning. But we don't think today they're internally consistent. That is, when you give us a performance number that looks like 130 tons and you give us a loss emission number that looks like 1 in 250, I'm probably going to tell you that I can't find a launch vehicle that will do that. And so we will be pushing back on some of those requirements. So some of the requirements have TBDs and TBRs still remaining, but I'm really happy with the effort that's going on to develop that set of requirements. We're pushing for a phased development approach. We're going to have to figure out how to, if policy is setting our requirements, we've got to figure out how to explain to Congress basically that we're going to get your 130 tons, but this is the way we're going to do it. And so we're pushing an approach that possibly starts out with test flights. I would like to even be able to say we could do some significant missions with 70 tons. I think we can. I think 70 tons is an incredible capability that we don't have today that we could go do a lunar mission with or HEO missions or send smaller payloads to even a NEO. I can tell you that there are some science missions out there that didn't make the decadal top list because of the cost of launching that payload. And if we've got a capability in this country to carry that kind of payload, again, capability driven, then I believe the science community, folks who want to go to Europa, for example, would certainly be interested in knowing that we had much more capacity than they needed and much more Delta V capability to throw a payload to Europa. It actually drives the cost down on the spacecraft because now they can relax some of their requirements. The trip time's a lot shorter. They don't have to be so stringent with radiation effects on avionics. It just waterfalls and multiplies, and now the science community, the science exploration community is starting to get on board and really look at that capability. We're happy to say that we're moving forward, that we're making one milestone at a time. I think we've got lots of options. I see a lot of positives in this because it is driving out some innovations that I don't think we would have otherwise been able to find. You got to stress the system to be able to innovate. And honestly, this country, we talked about it last night at dinner table a little bit, this country works better under stress. We are much better firefighters than we are planners. Get us in a bind, tell us we can't do something, tell us it's impossible, tell us somebody else is going to beat us to the pizza and beer, and we can do amazing things. And I kind of think that's where we are. We're in a very positive place right now, and the launch vehicle is going to be one of the first things. MPCV is going the same direction. Launch vehicle is going to be one of the first things to see the trend really change on our ability to get an affordable system. So I'll give you back a little time, I think.